Hello everyone, welcome to this session on advantages of high-resolution flexography for functional printing. I'm absolutely delighted to be hosting Carolyn Ellinger, General Manager of Printed Electronics at Eastman Kodak, and I do really think this is going to be a really interesting presentation looking at high-resolution, high-speed roll-to-roll printing, showing some applications like transparent antennas, and also talking a little bit about roll-to-roll printing of perovskites. So what's going to happen, as usual, is I'll disappear. 3 minutes before the end, I'll pop back in, just to remind everyone to type in their questions on the right-hand side. The room will remain open for an additional 10 minutes if you do have questions, and then Caroline will go into the lounge if you want to have a follow-up discussion. So with that, Caroline, the stage is yours.
Great, thank you, Kasha. So as we said, we're going to talk about some advantages of high-resolution printing, specifically by flexography. So I have quite a bit of content. I'm going to go fairly quickly through the beginning information so that I can get to some real-world examples of what we've done with our customers. But I'd like to reset at the offset and remind us that not all manufacturing that uses print has to be additive manufacturing. And so there are multiple reasons you may want to use print in your manufacturing process. And some of them are the obvious direct print, where it's pure additive manufacturing, where you're printing your additive material and it's a one-step kind of do it and once through print process. So that we call that direct print. You may print to define a pattern. So that's part of what we do in my organization. We print a catalyst and then we electrolysely plate. Which is additive manufacturing. You could also print an inhibitor to define a pattern, and I'll show an example of that. But you can also do subtractive processes where you print an etch resist, and that removes the photolithography requirement and can reduce the amount of chemistry consumed in an etch process. And so just some example of what those things might look like. So direct print, here's an example in the center. Where these are direct print conductive lines. The SEM micrograph at the bottom is a cross-section of a copper microwire that we've manufactured here in Rochester, New York, where we printed a catalyst, an electrolysely plated copper. The interferometric colorful pictures at the top have an inhibitor that were printed by Flexo, and then the active materials were deposited via ALDs, so the active materials only go where the inhibitor is not. And I couldn't find an example that I could share publicly of an active device where we've printed a resist, but this is something where I've printed a resist on silver to make jewelry, and it's the same concept, right? It's an etch resist that you've printed, and you print the material and generate the pattern. Sorry, there we go. Oh, sorry, I got a bit of a lag on my... So now let's talk about higher resolution. So why you might want to do print is to save on materials, have a lower cost of ownership. Why you might want to go to higher resolution is fairly obvious, probably to this community, that you want smaller individual feature size, but you also want finer increments in feature size, which is useful for defining curves and complex shapes, as well as finer control of placements of the features on the substrate. Think of things like aligning feature to feature and objects like gratings. And I'll touch on this again later in the presentation, but keep in mind that going to a higher resolution does not always require new hardware in terms of a new printing press. And so quickly, the impact of resolution shown on this slide is high resolution at 12,800 down to lower resolution at 2,400 DPI. And what you see for 20 micron line targets, which are the center lines of this bullseye target, at high resolution, you see very nice circles and spaces between the 20 micron features. When you get down to 2,400 DPI, you can tell that they're still circles, but it's really kind of not so great. If you go to even finer features that you're trying to generate on your substrate, so 10 micron lines and spaces, so 10 micron line, space, line, you can see at the high resolution 12,800 DPI, you have good pattern fidelity in the design. But when you go down to something like 2,400 DPI, the design cannot maintain your desired spaces and lines because the pixel size of the design is larger than your design feature. Just kind of to set the stage in terms of what you can get from flexography for a high resolution on plate design. So this is that same target from the previous slide. Again, 10 micron line, space line. For a bullseye target, put on the